In this video, we're going to look at the final part of the binomial expansion, which involves using partial fractions. So let's take this example here. So the first thing we ought to do is to write this as what we would do in partial fractions. So we would do a over 1 plus x plus b over 2 minus x. Now, if you're not sure how to go about doing partial fractions, please watch my videos on partial fractions. So what we do now, we say 4 minus 5x. Let's improve the clarity of 4 is identical to a times 2 minus x plus b times 1 plus x. So we want to make b equal to 0. So we say let x equal minus 1. So we get 4 minus 5 times minus 1 is equal to a times 2 minus minus 1. So that will give me 4 plus 5. And that will give me 3 lots of a. So 9 equals 3a. So we can say that a must be 3. So now to work out b, we're going to make the a bracket equal to 0. So we're going to say let x equals 2. So we're going to say let x equal to 2. So we get 4 minus 5 times 2 equals 2b times 1 plus 2. So that gives me 4 minus 10 is equal to 3b. So minus 6 is equal to 3b. And b equals to minus 2. So what we can do is rewrite our partial fraction as follows, that therefore 4 minus 5x all divided by 1 plus x and 2 minus x is identical to 3 over 1 plus x minus 2 over 2 minus x. So now that we have that, we can rewrite this as follows, that this is now equivalent to 3 times 1 plus x raised to the power of minus 1 minus 2 times 2 minus x raised to the power of minus 1. Now what we ought to do is to write down the expansion for this. So what we're going to do the following. 3 times 1 plus x raised to the power of minus 1. We'll do that first. And we notice that's going to be 3, open a bracket here, we're going to get 1 plus minus 1 times x plus minus 1 times minus 2 times x squared over 2 factorial plus minus 1 minus 2 minus 3 times x cubed over 3 factorial plus other terms. So what we end up with is the following, 3 times, now we can simplify what we have in brackets as 1 minus x plus x squared minus x cubed plus other terms. Now expanding that out, we'll get 3 minus 3x plus 3x squared minus 3x cubed plus other terms. Now, the next case is we're going to do the expansion of 2 times 2 minus x raised to the power of minus 1. Now that's going to be, we've done this before in a previous video, that must be 1. So it's going to be 2 times 1 minus x over 2, all raised to the power of minus 1. So in other words, it's 2 times 2 to the power minus 1 times 1 minus x over 2 raised to the power minus 1. Now don't forget 2 and 2 to the power minus 1, that's a half anyway, so they're going to cancel. So what I'm really interested in what I'm interested in now is 1 minus x over 2 raised to the power of minus 1. So now we're going to use the binomial expansion for that. And what we end up with is the following: 1 plus minus 1 times minus x over 2, we must be very careful there, plus minus 1 times minus 2 over 2 factorial times minus x over 2 all squared. Let's do another term, plus minus 1 times minus 2 times minus 3 over 3 factorial times minus x over 2 all cubed, plus the terms here. And if we were to expand that out, we would end up with the following. We would end up with 1 plus x over 2 plus x squared over 4 plus x cubed over 8 plus other subsequent terms. Now don't forget, it's also minus 2 times that. So because it's minus 2 times all of that, and we simplified the 2.5 to cancel out, I need to minus all of this. So what I'm going to do, I'm going to write this out a bit more clearer. So I'm going to write it as 3 times 1 plus x raised to the power of minus 1. And then we have minus 2 times 2 minus x raised to the power of minus 1. Now this minus in the middle is going to affect the other terms, so we need to be careful there. So we're going to, what we end up with is 3 minus 3x plus 3x squared minus 3x cubed. Now be careful, it's minus all of what we have just now, 1 plus x squared over 2 so don't forget we need to minus 1 and x over 2 plus x squared over 4 plus x cubed over 8. So if you were to simplify that down, so you would get 2 minus 7x over 2 plus 11 over 4 times x squared minus 25 over 8 x cubed plus other subsequent terms in our series. So if the question stated find which the series expansion is valid for, so what we would do, we would say, well, 3 over 1 plus x, that's valid if mod x is less than 1, or in other words, x is greater than minus 1 but less than 1. But 2 over 2 minus x, don't forget we've already simplified that down. That would be, now because we wrote it as follows, 1 minus x over 2 raised to the power of minus 1, we take the minus x over 2 out. So it will be the minus of x over 2 is less than 1. In other words, mod x over 2 is less than 1. Cross multiply here. So mod x is less than 2. So in other words, we can say x is greater than minus 2 but less than 2. So if I draw my inequality out, I've got the range of minus 2 and 2, like so. But I've also got the range from minus 1 to 1. And they must be clear circles because they're not equal to. So let's draw them in. But it's asking for the inequality that satisfies both of these series expansions. And the only one that does is when x is greater than minus 1 but less than 1. So we can say the one that satisfies both is when x is greater than minus 1 but less than 1. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we've got the following: a over 1 minus x plus b over 2 plus x. You want this in partial fractions, so we're going to write that as 8x plus 4. And we want the first 3 terms of the binomial expansion later, which is going to be a times 2 plus x plus b times 1 minus x. So we want to eliminate b, so let's make x equal to 1. So 8 times 1 plus 4 equals to a times 2 plus 1. So 12 equals to 3a, a equals to 4. Now we want to eliminate a, so we're going to say let x equals to minus 2. So I get 8 times minus 2 plus 4 equals to b times 1 minus 2. And what we end up with is as follows. We get minus 16 plus 4 equals to 3b, minus 12 equals to 3b, so b equals to minus 4. So we could rewrite our partial fraction as follows. We could write it as 4 over 1 minus x minus 4 over 2 plus x. So we could write this as 4 times 1 minus x raised to the power minus 1 minus 4 times 2 plus x raised to the power of minus 1. So if we take the first one, 4 times 1 minus x, all raised to the power minus 1, that's going to give me the following: 4, and that's going to give me 1 plus minus 1, which is n, times minus x. And we only need to go up to x squared, so it's minus 1 times minus 2 times minus x all squared over 2 factorial. plus other terms. And that will give me 4 times 1 plus x squared plus other terms. And that will give me 4 plus 4x plus 4x squared plus other terms in our series. Taking the next one, we now have 4 times 2 plus x raised to the power minus 1. We need it to be 1 plus x, so it's 4. Take the 2 out, so we get 1 plus x over 2, and all of that is raised to minus 1. So it's 4 times 2 to the power minus 1 times 1 plus x over 2 raised to the power minus 1. That gives me 2, so it's 2 times 1 plus x over 2 raised to the power minus 1. So we can now use the binomial expansion here. So it's 1 plus minus 1 times x over 2 plus minus 1 minus 2 over 2 factorial x over 2 squared plus other subsequent terms. So simplifying that down, we get, so that's 2 times 1 minus x over 2 plus x squared over 4 plus other subsequent terms there. And then we'll end up with 2 minus x plus a half x squared plus other subsequent terms. So now we want to combine the two. So we're going to say that 4 over 1 minus x minus 4 over 2 plus x, or in other words, 4 times 1 minus x raised to the power minus 1 minus 4 times 2 plus x raised to the power minus 1. So we want to combine this, so it's going to be what we had previously, so 4 plus 4x plus 4x squared minus what we just found out, 2 minus x plus a half x squared plus other subsequent terms. So that ends up with 2 plus 5x plus 7x squared over 2 plus other subsequent terms in our series. So, like the last one, we want to find for what the series expansion for is valid. So 4 minus x, that's going to be mod x is less than 1. 4 over 2 plus x, don't forget we say mod x over 2 is less than 1. So it means mod x is less than 2. Don't forget x over 2 comes from rewriting 2 plus x. And we could write out what this means. It's x is greater than minus 1 but less than 1, and x is greater than minus 2 but less than 2. And as we had previously, you can draw our inequalities in. And don't forget we've got minus 1 and 1. And what we need is the one that satisfies both. And that's going to be, as previously, when x is greater than minus 1 but less than 1. That's our solution.